Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'm Duggan, and I'm joined by Paul, and we'll be your hosts this evening.
Hi,
We are broadcasting live from the Alani Carswell Observatory, located at York University in Toronto, Ontario, Canada. This is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Quarks and Quarks, Western Worlds, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at 2 a.m. UT for EST, or 1 a.m. UT for Eastern Daylight Time. The York Universe production works in concert with our online public viewing program, run by the Observatory team, which runs between the hours of 9 to 10 p.m. local Toronto time. Go to observatory.info.yorku.ca and follow the links to OPV and join. You can always connect with us on Twitter or Instagram with the handle at York Observatory and on Facebook at Alani Carswell Obs. So, sorry for that little mix-up. Haven't hosted in a while. How are you?
Oh, the practice is always helpful. Don't worry about that. And I interrupted you anyway, just to throw you off.
It'll be a smooth intro for me soon.
It will indeed, absolutely. You've come a great long distance, Kagan, since you joined us years ago now. But it's terrific to hear you on air so much.
Thank you. I was surprised to not see you on the schedule this year, and then I remembered you're enjoying the retired life.
I am. It's one of the best jobs going. I kid you not. You will see me around occasionally, but I've certainly been doing a lot of travel over the last sort of 6 weeks, and I'm actually back teaching on for the summer. I've picked up 2 astronomy courses. I can't leave it alone. So you'll actually see me around on campus Tuesdays and Thursdays.
Oh, amazing. I'll make sure to come visit.
Yes, please do. Absolutely. Although no longer in my office. I had to give my office key back in that regard.
Oh,
yes. So you'll still find me either in 211 or upstairs in the observatory.
Okay, I'll make note of it for sure. I was actually going to ask you, how was the life finally without students, but I guess it didn't go too far.
Oh, hey, I like my students, as you well know. So teaching in the summertime is not a chore in any way, shape, or form. And they're the courses that I like to teach. They're both astronomy courses. And I don't have to sit on any committee. So it's great. Not a problem there at all.
It's all the perks.
You got it. Exactly. And in the summertime, as you know, campus is fairly quiet. So, I think it's great.
Oh, it's lovely because I'm on campus most days now anyways, and I don't miss the rush.
You mean standing in Tim Hortons lineup for 10 minutes to get a coffee? You don't miss that?
Oh, that used to be the best part of my day.
It's precisely right. Anyway, shall we get on with the evening?
Yes, absolutely.
Lead on, my dear.
Thank you. I'll get started with 53 years ago today. We're going to start off with a Venus mission, the Venera 5, and actually Venera 6 as well, which launched 53 years ago tomorrow. So the Venera 5 probe is a Soviet mission series, the Venera program, and it was dedicated to the exploration and research of Venus. And the Venera 5 probe actually entered the Venus atmosphere 53 years ago today, making it the second probe to successfully enter the Venus atmosphere. Venus's high surface temperatures and pressures make it really difficult to collect data from anywhere closer than Venus's orbit, basically, because surface temperatures can reach up to almost 500 degrees Celsius and pressures up to almost 95 atmospheres, so 95 times the surface pressure at sea level on Earth. It's basically a hellscape of extremely hot rock, some active volcanic activity, and suffocating atmospheres, which is basically mostly carbon dioxide. And the Venera missions actually set a lot of precedents for planetary exploration. The first ones were the first missions to explore Venus, and they were also the first missions to enter the atmosphere of another planet. Venera 5 built upon what its predecessors did, and used the Venera 4 data to build a probe that could survive in the Venus atmosphere a little longer and transmit more data back to Earth, because Venera 4 didn't survive very long at all. It People thought it was planned to land Venera 4, but further analysis of the mission data revealed that it actually burned up in the atmosphere before it could actually land and reach the surface. So the Venera 4 was only able to transmit data on Venus back to Earth for a really short time. It didn't reach the surface because the atmospheric pressure crushed the ship's hull. It's unknown exactly how long the probe maintained power, but Venera 5 and 6 were designed to be atmospheric probes instead, never meant to land. And Venera 5 actually meant to manage to survive in the Venus atmosphere for longer than any other probe, which was actually only 53 minutes. So this whole mission ended up was about a 53-minute long data retrieval period. And that's when it lost power, basking in the balmy Venusian climate, or cooking over there. And Venera 5 was actually identical to the Venera 6 probe, and both were launched and reached Venus around the same time, with Venera 6 reaching on May 17, 1969. They both collected very similar measurements, such as the temperature, pressure, and data for the measurement of the Venus atmosphere and its composition. So they definitely contributed a lot to our understanding of Venus, and of course, set a precedent for further planetary space travel in the future.
You forgot one of the more charming aspects of the Venusian environment. It rains sulfuric acid, just for good measure.
Oh my goodness, I can't believe I forgot that. That's like my favorite part. I wish we had that here.
Yes, whichever way you cut it, the Venera missions were surprisingly successful, given, as you said, the hellish environment through which they had to fly. And initially, of course, we were quite surprised, and the conditions were very unexpected. The Soviet Space Agency really adapted well, eventually, of course, putting Venera probes onto the surface and transmitting back our only imagery from the planetary surface. So, yeah, the Venera missions really were standouts with respect to planetary exploration, especially given when it happened. I mean, we're talking here, the sort of the mid-1960s. We weren't, well, mid to late 1960s. It really did a grand job when all was said and done.
Yeah, absolutely. And I guess back then, with the space race in full swing, I guess funding was near unlimited.
It certainly was. There was certainly a lot more money to throw around. And interestingly, the Soviet space program went after both Mars and Venus with equal zeal in the 1960s. They tended to specialize in Venus in the 1970s, whereas NASA decided that they were going to specialize in Mars. Generally speaking, the history of planetary exploration for Venus has been the domain of the Soviet Space Agency, and the exploration of Mars has been the domain of NASA. It's now broadened, of course, with ESA and China and so on. But for literally many decades, when you said Venus and planetary exploration, you really did think of the Soviet era. And when you think about Mars, you think of NASA. I'm glad that is changing now, though.
Yeah, definitely becoming a more planet-wide, Earth-wide effort, with a lot of, especially last year or the year before, with all those probes being sent up to Mars.
That's
I was
true.
glad that we got all those successful missions out.
3 of them, absolutely. That was really good stuff there in February of last year. Everybody going into orbit safely, and everybody is still operating. I mean, the Chinese probe both in orbit and on the ground, the rover, as well as the United Arab Emirates mission in orbit, continuing to operate just fine. The European Space Agency has got a couple of missions in orbit around Mars. And when we pop over to Venus, both the Japanese Space Agency, JAXA, as well as the European Space Agency have joined the party, shall we say, in Venusian exploration. I can't wait, actually, for the next few years, because there are no fewer than 3 probes on the books being developed to send to Venus before the end of this decade. So we will finally get some I guess, increased surveillance of Venus, something which has been, generally speaking, sorely lacking over the decades.
Yeah, for a planet considered Earth's sister planet, it really hasn't, it's definitely not the favorite child of our solar system.
Well, it can blame its environment for that, can't it?
Yeah, so hot-tempered.
We'll go with that. Okay, let me drag us back to the local environment, in fact, low Earth orbit in particular. May 18th, 2009, so about 13 years ago, saw the final spacewalk on the final servicing mission to the Hubble Space Telescope. All right, I don't think we really need to remind people of this, but the HST is often thought of, often referred to as astronomy's discovery machine, and it was launched April 25th, 1990. So it's 32 years old and counting. Not half bad. It was originally hoped, shall we say, its primary mission was expected to be 5 years, probably 10, and here we are 30 years and counting later. Really good effort from the Hubble Space Telescope. Of course, we all will remember, and I remember it vividly, and you probably have read about it, Gagan. It was in difficulty from the outset because the mirror had been ground perfectly incorrectly. It had spherical aberration. And this telescope, being in a pristine environment, low Earth orbit, it was expected to be diffraction limited, giving us really unprecedented views of, the night sky. So we're talking about 10th of an arc second or less was the expected seeing. And you can imagine how disappointed we were when the best focus we could generate was really only about 1 arc second in seeing, and as I said, spherical aberration. So really bad news. And that wasn't a good way to start. Fortunately, ingenuity and the space shuttle came to the rescue. And in 1993, the first servicing mission was launched, basically taking up a set of optics that would allow the spherical aberration to be corrected prior to entry into any of the suite of instruments that were on board the Hubble Space Telescope. So they sacrificed one slot to put in this corrective optics suite, and the light path, now a little bit torturous, but basically the light properties were corrected, and now diffraction limited optics had been returned to the telescope into all of the instruments. So, it was a phenomenal effort. It was the first of 5 servicing missions that would fly to the Hubble Space Telescope. So started in 1993. The final one was in 2009, May of 2009. It was actually called May 2009. It was the 5th servicing mission, but it was officially Service Mission 4. Yeah, some people just can't count. What can I say? They did 3A and 3B. Not real clear why they did that for a numbering system, but that's besides the point. Repair, replace, update really were the motto of all these servicing missions. And, it really is quite phenomenal. We went up, and just about the only thing that remains from the original launch is the mirror. Everything else has been replaced. All of the solar panels over the years were replaced. The computer systems were replaced. The gyros were replaced multiple times, and so on and so forth. That 5th servicing mission was not meant to fly in 2009. It was meant to fly considerably earlier, and we were anticipating even more servicing missions. But unfortunately, the tragedy of the Columbia Space Shuttle disaster in February 2003 changed all of that. NASA's thinking basically was we will no longer fly space shuttle missions anywhere that could not reach the International Space Station, what they referred to as a safe harbor. So we could go into orbit and we could still do science independent of docking at the International Space Station. However, if there was a problem with the shuttle, aka, like what happened with Columbia, we would have the option of flying the space shuttle to the International Space Station. Unfortunately, the orbit of Hubble and the orbit of the ISS precluded a shuttle being able to reach both places. And so NASA essentially said, we're not going up to the Hubble any further. That caused a huge hue and cry back in 2004. And over the ensuing years, a lot of congressional persuasion was engaged in, a lot of public writing was engaged in, and eventually NASA, under the new administrator in 2006 or thereabouts, gave the go-ahead for a fifth and final servicing mission, because by that point in time, the space shuttle era had been declared to be coming to an end in 2011. So the last servicing mission was going to fly, and that ended up being in May of 2009. It was Atlantis that flew that mission, and amongst other things, we replaced the computer systems on board Hubble. We also replaced all of the gyros. We put in 2 new instruments. Just about everything was replaced. And the mission was a startling success. It worked really, really well. And to this day, 13 years later, Hubble continues to work very well. It has had a couple of little glitches. I mean, this is 32-year-old technology that's in orbit, which means, of course, it's the technologies from the 80s with all of the changes and so on. But, there's a lot of original hardware still on board. And to think that it is working as well as it is 32 years later is, in my opinion, quite outstanding and a real testament to the capabilities of the engineers and the planning of those engineers that went into the original Hubble Space Telescope. At any rate, there we go. The last of the shuttle repair missions, the shuttle servicing missions to the Hubble Space Telescope. Fifth and final service mission number 4 this day in history, May 18th, 2009. 3 cheers for Hubble.
I'm glad they decided to go back up, because even this 4th servicing mission postdates the expected end of Hubble's service time by 4 years. And the fact that it's still running here in 2022, after, such a big hiccup at the very beginning of its service time, just goes to show how well NASA was able to adapt to whatever they had. And Hubble has done amazing work for us. I'll be sad to see it retire in the next hopefully 10, 15 years. Maybe it'll make it to 2040. Who knows? But with I assume it'll be retired into the Indian Ocean at some point.
Probably
before then, especially with the JWST almost in service in about a month.
Well, of course, there was always the expectation that there would be a small amount of overlap between Hubble and JWST. You might recall JWST was supposed to launch initially in 2007, and then they thought, we should be up by 2011. Can we keep Hubble going till then? And, well, as we all know, James Webb finally launched in December of 2021. The fact that Hubble has hung in there so very well, as we've just been saying, is a real compliment to everybody. But I certainly do remember those heady days, those first few years, where the spherical aberration was confirmed and everybody was sort of very dour and sort of glum. And then some bright person came up with the idea of the corrective optics being put on, and the tortuous light path of the instrument having to be installed by glove-wielding astronauts into the Hubble Space Telescope. Most of us sort of looked at this idea, this plan, and thought, really? Can we really do this? And then in 1993, they did it. And the first images that came out were so markedly better than the previous images from the previous 3 years. It just, it made you believe that NASA could do just about anything, really. It was that big an improvement. And now when we compare the Hubble images with some of the images that have already, they're not science images, but some of the engineering images that JWST is generating, it's just beautiful. The improvement in the technology as we've moved and learned from Hubble to go into the JWST era. Gosh, those first images, science images in July, Gagan, are going to be spectacular. And a common friend of ours, whose name we will just say is Sana, is going to be, I think, on such an adrenaline high when those images come out.
Oh, I think that'll be probably one of, I would say, top 10 of her days in academia to date, for sure. I don't know anybody more excited about telescopes, but I guess in part the longevity that Hubble afforded us kind of allowed for all that extra testing to go into the JWST, which I guess was a good thing. But I hope they do have some considerable overlap over the next few years.
I think Hubble will be continued to operate, be allowed to continue to operate until such time as it fails. I would be hard pressed to see NASA canceling the relatively modest funding. I mean, it's not insignificant, but it's still modest in the grand scheme of things. I can't see NASA folding Hubble up until such time as either there's a catastrophic failure in the computer system or the gyros literally are no longer able to stabilize the system. I mean, they've had a little bit of a challenge over the last couple of years, chasing down some software/hardware irregularities in the system. They've fought their way through those problems. But I think, everybody would have to believe that those types of challenges are only going to continue. You've got a spacecraft that is 32 years old, and even though I sort of tongue-in-cheek have said that we've replaced everything on board except the mirrors, that's not quite true. There really is a lot of original hardware there, and it's being steadily cooked. It must be degrading, but I don't think NASA will pull a plug until such time as Hubble is truly dead.
No, I really don't think they'll be retiring it before it's ready.
Quite correct. One other thing that they did do on that fourth and final, well, the fifth servicing mission 4, they actually did put a grapple mechanism on Hubble to allow for either an automated or human vehicle to nudge up and snag it in preparation for its final demise. So they were forward thinking in that regard. You're right, they probably will ditch it into the Pacific Ocean, which I think is sad, but there's just no capability to safely bring this vehicle back. We couldn't have even put it into the shuttle payload bay and bring it back. It just was, too heavy for a re-entry type process. So unless somebody comes up with a very ingenious way to allow Hubble to survive atmospheric entry, and I don't know how that would happen, I think we'll either leave it in orbit or maybe, just maybe, that grapple fixture will be used for a space tug to take it into a higher orbit and leave it as a museum piece in orbit. That, to me, is a distinct possibility, but we will not see it in the Smithsonian Institute in Washington, D.C., I don't think.
I'm disappointed. That was one of my biggest plans, was to go there when it was finally there.
You'll just have to take a trip into Earth orbit and go via the higher orbit of where they will finally decommission Hubble. There you go. There's my prediction for the 10 or 20 years into the future.
I'll volunteer to operate the grappling hook. I wonder if they'll let me close to it.
I hope so for you. I don't know whether they will, but hey, it would make so much sense for a Canadian to be at the controls of a Canadarm that was snagging Hubble and taking it to its historical resting place in high Earth orbit.
I think if I can convince, I think you and the rest of the observatory team to let me use the 1 meter, I think Hubble is not too far of a stretch for me.
Oh, I wonder whether Elena is listening. Shall we proceed?
Yes. So on the same date, May 18th, but a little while earlier, also 53 years ago, 1969, which I'm sure, as you all have guessed, is a busy year for space travel, Apollo 10 was launched. So Apollo 10 was, as logic follows, the 10th mission of the Apollo series, and it was launched from the Kennedy Space Center, and it was the dress rehearsal mission for the Apollo 11 moon landing, which kind of interesting, not exactly a high school theatrical performance. Why do we need a dress rehearsal? But NASA was very intent on making sure that Apollo 11, the moon landing mission, went as smoothly as possible. So John Young, Gene Cernan, and Thomas Stafford all suited up and they went up to the moon and they went through the entire mission down to every last detail, except crucially, landing on the moon. So they did a few orbits after launch. They got there. They were in orbit with the command module, from where Stafford and Cernan launched the lunar module and descended to within 15 kilometers of the surface of the moon. All the while, John Young stayed in the command module in orbit. So these two, they didn't land or disembark from the lunar module. So they just kind of got a little close and then went right back up to the command module. The lunar module descent was actually a little rocky. There was a mistake in entering the maneuvers for the descent, and it was actually dangerously close to being an utter disaster that could have resulted in the lunar module crashing into the moon, which I'm sure would have been catastrophic for the future of the Apollo program. But thankfully, the crew was able to control the module and complete the mission as planned. All three of these astronauts actually went on to partake in further lunar missions, with Young and Cernan actually landing and doing moonwalks with Apollo 16 and 17, respectively. Unfortunately, Stafford was the only one who wasn't able to walk on the moon, but he did go back for the Apollo Soyuz mission. And they also were able to take an Earthrise video from around the moon, which is pretty cool because I believe you can find the video on the Wikimedia, on the Wikipedia site. So it's pretty cool to see Earth coming over the lunar horizon in video, not just in a picture. And while they were there, they also surveyed the Sea of Tranquility, which was, of course, the planned Apollo 11 landing site. It was, in general, a crucial mission that led to the overall success of the Apollo programs and its further missions, including the first successful moon landing. So, and it really was, we mentioned this earlier, the space race was in full swing. The late 60s and early 70s were super busy, where they were super busy decades for space exploration, and NASA made it to the moon first. So Earth visits to both the moon and Venus and several other places in space throughout that time. But this was one of the successful missions that really led to the future of space travel and really laid the groundwork for all the future Apollo missions.
NASA certainly was very methodical. After the loss of the Apollo 1 crew in January of 67, the Apollo fire, the return to flight 18 months later, Apollo 7, it was the beginning of a very deliberate collection of steps that would take them to the moon. Apollo 7 took astronauts into Earth orbit and proved that the Apollo architecture would survive the necessary length of time to the moon. So they were in orbit for about 10 days. Then Apollo 8 flew to the moon in December of 68, and that showed that the Apollo architecture could go to the moon. They orbited the moon, and then they came home again. Apollo 9 took the lunar module into Earth orbit for the first time, and they practiced docking and undocking, again, the Apollo architecture that was going to be needed to go to the moon. Then, as you said, Gagan, Apollo 10 took that whole kit and caboodle, and we went to the moon and flew within 15 kilometers of the moon. I mean, really, you could just about reach out and touch it. But they came back, and that set the stage for the Apollo 11 in July of 1969. Very methodical, very deliberate, but very, very exciting. That 2 years from 68 through 69, well, a year and a half, was so many differing launches. August of 1968 Apollo 7 through to July of 1969 Apollo 11. They were launching every 2 months. It really was exciting, and you could feel the world gaining in excitement as we drew closer and closer to Apollo 11. But Apollo 10, that mission in May, and it was in and around my birthday, so I remember it vividly. It just was one of those things where you went, why don't they just go down and be done with it? But that wasn't the plan.
No, they had to go through all the motions first. And I can't imagine being Stafford and being the only one on that mission and the following mission and a couple missions afterwards not to reach the lunar surface. But I guess Michael Collins also got a taste of that.
Yeah, that's right. Exactly. Yeah, there were a lot of, there weren't too many astronauts who went to the moon twice. Stafford, Cernan, and Young were three of those folks. And as you say, Stafford actually never got to the moon's surface, but he got to the vicinity of the moon. And John Young, of course, ended up flying Gemini, Apollo, and Shuttle, one of the very few astronauts to have done that. So he had a very distinguished career. Apollo 10, I don't know whether or not he would think of that as the highlight. I imagine his flight with Apollo 16 he would have thought of as the highlight. But yeah, Apollo 10 was very special to many, many people.
Right, absolutely.
All right, let me finish this off by charging off in the other direction over towards Mars and the Phoenix mission, which landed on May 25th, 2008. Now, I know that sounds a long time in the future. I mean, today's only the 16th and, the 25th I'm talking about, but we're not going to be live on air for a couple of weeks. So I figured, okay, I'm going to snag this one because, of course, it has a distinct York University connection. Anyway, before we get to that, the Phoenix mission was the sixth successful Mars landing by NASA. The first ones, of course, were the Viking missions all the way back in 1976. So this is considerably later. But this one was somewhat special in that, unlike the other missions, which all tended to land relatively close to the equator to maximize solar energy availability, Phoenix was sent up to latitude 68. And of course, just a quick little think about that, that means, of course, that the sun is eventually going to set at that latitude because, of course, Mars's obliquity, its axial tilt, is about 25 degrees, just a little bit over what we've got here on Earth. At 68 degrees north latitude, the sun does set, and that's bad news as far as solar panels are concerned. But we went that far north deliberately to have a look at that ice-soil interface. Mars has a lot of subsurface ice, and we wanted to make sure that we understood what that ice characteristics were, and Phoenix was dedicated to basically a 5-month mission. It landed in May. Its last contact was November 2 of 2008, so that's about a nearly 6-month mission lifetime, so it did very, very well. It accomplished all of its mission objectives, no question in the world about that. Everybody hoped that it would survive the Martian winter, but that was a forlorn hope. There was just no way it was going to happen because literally with no sun above the horizon, no charging from the solar panels, winter nights at minus 100 degrees Celsius, there was no way Phoenix was going to survive. Nonetheless, it was very successful for the 5 months that it was there. There was a strong Canadian contribution to this mission. The meteorological package was built by, was backstopped by the Canadian Space Agency, was built by the Toronto firm Optech. That was formed by Dr. Alan Carswell. And the mission scientist, the principal investigator, was Dr. James Whiteway from the Lausanne School of Engineering here at York University. So, big, strong connection there for the Phoenix mission. The meteorological package, as you can well imagine, was there to eavesdrop on all of the atmospheric conditions, so the wind, the temperatures, and so on. It was using LIDAR, that's laser-based radar, popping up into the atmosphere and therefore measuring the atmospheric components. And perhaps one of the really neat things associated with the meteorological package is that they discovered snow falling from the clouds. So high altitude clouds at the 3 to 4 kilometer area, they were able to detect with the LIDAR water vapor in the form of solid crystalline snow streaming from the clouds. It doesn't reach the surface where, I'm sorry, can't allow skiing on the surface of Mars, but nonetheless, the actual process of snow formation and fall was detected by LIDAR. Seems very appropriate that us Canadians were able to find that at that northerly landing site. So the Phoenix mission, 5 to 6 months worth of forensic activity, but the data that they collected the ice analysis and so on. It was a spacecraft that had a lot of great science return, even though its length of life was, by NASA missions, relatively short. Phoenix, May 25, 2008.
It always amazes me how much York University has contributed to astronomy and space in just in general. I was doing some digging today and I was looking at historical records from the early stages of research conducted at the observatory here back in the late 60s and early 70s. And it was actually, I actually found out that it was um, the initial research conducted was in conjunction with the Harvard Observatory. And we have lots of connections, lots of old papers that are out in the NASA archives that you can go and look at. But it's just amazing how much we actually are able to see. And I think even with some of the more recent programs, OPTEC has been involved. We have several other researchers in the astronomy department who have had viewing time with several of the major missions, Mars rovers, everything of the sort. I'm glad we have such a strong astronomy presence and um, activity, a flurry of activity really going on at Petrie here.
It's very true. One of the people who were very involved with the Hubble Space Telescope, just going back to that mission in particular, but also associated with Galileo, was the late Dr. John Caldwell. He was a guaranteed time observer on Hubble. He was one of the PIs associated with the Galileo mission to Jupiter in the 1990s. He was one of the world leaders in understanding the Jovian environment. And then he transitioned in his later career to the Kepler mission. So he was a strong proponent of planetary science. And of course, our own Dr. John Moore's, his involvement with the Huygens mission, and since then, Curiosity, so on Mars. So there has been, as you say, Gagan, a lot of activity associated with space missions as well as planetary science that has come from York University over the many decades. So it's a great environment to be in, rest assured, for both professors as well as graduate students.
Yeah, definitely a lot of opportunities for them to get experience with research on some of these huge missions, in association with their PIs.
Absolutely. It's good stuff. It's good stuff.
All right. Let's move on to the reminders for today. We got a little carried away with this week in history, but
What's new?
nevertheless, not much, except we are going back to in-person tours at the observatory, which, as you all know, if you've been keeping up with York University for the past few months, we are transitioning back to in-person tours in light of recent restrictions lightening up with the COVID-19 pandemic. So this Wednesday, May 18th, 8 p.m. to 9 p.m., the observatory will be running an in-person tour for students, faculty, alumni of York University in particular. So you will need a student ID to be able to get in. But if anybody is interested in this event, tickets are available on Eventbrite. And all the information related to the event, including the link for the Eventbrite tickets, which are, of course, free of charge, is located at observatory.info.yorku.ca. So you can head right over there, look at public viewing, and there should be a link to our public tours right underneath. So we'd be excited to see you back on campus after a few years. So please come by and visit.
Nothing like standing in the shadow of the 1 meter telescope. It's really, really very exciting. But I believe that the activity for this coming Wednesday, correct me if I'm wrong, Gagan, or you mightn't be sure, is actually over on the Arboretum with the 40 centimeter telescope.
I'm actually not quite sure. They have been switching between the two. I do believe that they have been doing some in-person tours at the 1 meter in the past few months. But I'm not sure about this Wednesday's event in particular.
Okay, well, it could be at either location. Regardless, both telescopes are really sweet. All we need is a bit of nice clear skies, and you'll get a wonderful view around the skies. The only reason that I think we might be over at the Arboretum is that we're slowly transitioning to the time frame associated with the dome replacements. And that means, of course, that both the 60 centimeter and the 1 meter telescopes are going to be secured, shall we say, for their environment as we change out our 54-year-old domes. And so by the end of the summer, in fact, perhaps by the end of July, we'll have two brand spanking new domes covering our 1 meter and 60 centimeter telescopes.
It's the even the last time I was up at the observatory for a full summer, um, we also were undergoing construction and renovation at the observatory, but that was for the installation of the 1 meter telescope, which was August 2019. So we've been happily enjoying our observing hours on that one since, but hopefully these new domes afford some more smoothly going winter observing because they do screech and moan unhappily when there's snow and ice on top.
Oh, they sure do. No question in the world about that. 54 years has, worn them down a little bit, shall we say, and they're not quite as weather tight as they once were. But all of that is soon to become history, shall we say, as we get new domes in place. So that will be exciting over this coming summer. Last night, of course, Gagan, there was a wonderful total lunar eclipse visible just about across all of the Americas and certainly visible across all of Canada. Even Vancouver was able to see totality in all of its glory. Unfortunately, we had a little bit of cloudy skies here in southern Ontario. Did you manage to see any part of the eclipse last night? Did you find a big sucker hole that you could see the moon through?
Unfortunately not. I had a great view of the clouds though, which I mean, who doesn't love seeing the clouds on in an important observing night? But
Yeah, we had
I
such clear
did,
skies all week too. I mean, just about the previous 6 nights were all
yeah,
clear, and then it began to break down last night during the eclipse.
yeah, used up all of our good luck for the week. But I did see some amazing pictures, so it looked amazing. And I think the observatory they did run an event last night, so I believe they
Yep.
did get some brief windows of viewing time, maybe not around totality, but a little bit before and after.
You're absolutely right. During the full moon rise and then during the early phases of the partial eclipse, they were transmitting live imagery from our 40 centimeter telescope. I think around the time of totality, as you pointed out, the local cloud began to thicken. But fortunately, of course, we have a link up to Killarney Park these days with the Killarney Astronomer in Residence program that is now active up there. Killarney Park looked to be quite clear, and they were transmitting to YouTube on the observatory's YouTube channel. So there was certainly some positive viewing in that regard. So not necessarily from the York campus, but certainly from shall I say, a York affiliate there at Killarney Park.
Yeah, absolutely. And I do believe that the replay of last night's event will be up on the YouTube channel, so you can also find that on our website. So if you haven't taken a look so far, please do. There have been lots of amazing viewing opportunities and lots of observatories running viewing events across North America.
Yep, absolutely. Lunar eclipses are special in that regard, but gosh, the night sky is full of wonderful things. So I look forward to the replay, and there's lots and lots of good stuff on the observatory's YouTube channel.
Yeah. All right. Shall we move on to our news stories for this week?
I think so. We've got a couple of good ones to chat about.
Yeah. So let's get started with something a little local, but not too local. So, as most of you probably know, the Milky Way, along with many other galaxies in the universe, has its very own black hole at the center of the galaxy. And this black hole is what we call Sagittarius A. So, astronomers, as many of you, if you were a part of the astronomy scene back in 2019, you might recall that astronomers imaged a black hole in Messier 87 for the very first time in 2019, making it the first black hole ever imaged, the first black hole we've ever seen a picture of, except unless you saw the movie Interstellar, which is adjacent to a real image, but not quite. So the thing is, we didn't actually see the black hole itself, but we did see the last traces of light kind of falling into it around its event horizon. So it's more like the silhouette of the black hole and its event horizon that we see in these pictures. The actual singularity, much more difficult to ever visualize, and I'm not sure we ever will because just of the nature of its existence, there's no light and we can't see past the event horizon. But nevertheless, the event horizon itself, massive accomplishment. So this feat actually took several radio telescopes around the world that were all collecting data in sync as part of the Event Horizon Telescope project. And a few days ago, the EHT project struck again, unveiling the first ever picture of the Milky Way's own black hole, Sagittarius A. And these data were actually collected at the same time as the data from the Messier 87 black hole. So they were all these data was collected in 2017. And the astronomers actually took 2 years to process the data from Messier 87 and 3 years longer to process the data from Sagittarius A. And while Sagittarius A is much closer than the Messier 87 black hole, it is also much smaller. So it's a little bit harder to take a look at. And in totality, the 7 observatories that collaborated for this project collected over 4,000 terabytes of data. So for the data processing, it actually had to be transported on physical hard disks around the globe to different astronomers and the computer scientists and image reducers and everybody working on the project to be able to compile 4,000 terabytes of data into the one image of the black hole that was released a few days ago. So this was really cool. So now at this point, we've seen 2 black holes, and I'm told that previous depictions of black holes in media were pretty accurate. So this is, you can see they are both very reminiscent of things that you might have seen in the past, but it really is amazing to see. And one of the cool things about this discovery is that while it was very heavily theorized, theory almost to the point of law that there was a black hole at the center of the Milky Way, this is definitive, absolute proof that that is a black hole that we're seeing. So Sagittarius A, that object that's kind of controlling the flow of the Milky Way, it is a black hole, and here it is, and you can see it on your computer screen. So this is a really amazing news story that came out over the last few days from the Event Horizon project.
Almost every aspect of this story, to me, is quite stunning. You've indicated that there were literally hundreds of scientists processing hundreds of terabytes worth of data with computing time that sort of is measured in years to be able to produce this, one image, so to speak. Sort of the tip of the iceberg is the image we saw last Thursday or Friday, whenever it was. But all of the other formulations, all of the other imaging, all of the other modeling that had gone into this one particular image, years and years worth of people's lives generating it. It's just remarkable in that regard. The Event Horizon Telescope, as you indicated, long baseline interferometry, basically turned the planet into one big radio dish. So, over 10,000 kilometers wide was effectively the aperture of the radio telescope of the Event Horizon Telescope. That, to me, is also stunning. 10,000, giving them, of course, milli-arc second resolution, which is what you need when you're looking at an object that is, in the grand scheme of things, relatively small. The Milky Way's black hole, 4.3 million times the mass of our sun, but it really is only something like, if memory serves, 40 or 50 million kilometers in diameter. 27,000 light years away, 40 million kilometers is not very big, and its apparent angular size is really small. So to be able to see the sorts of detail that were released with this image, it's truly a miraculous effort by the entire Event Horizon Telescope Consortium. Just, mind-blowing stuff.
Yeah, and included the radio telescopes in Greenland all the way down to Antarctica. So you're right. The whole Earth was basically a radio dish just to collect this one image, which was, or at least the data compiled for this one image, which is an amazing feat, but crazy how much goes into the work like this. Like we tend to take these images at face value, but we don't really see all the work that gets put into it behind the scenes.
If you compare the images from M87 and the image from Sagittarius A star, they certainly are similar images, but they are also distinctly different. They have some distinguishing features. If you look at the Sagittarius A star image, it definitely seems a little fuzzier, a little blurrier. And you might be tempted to say, oh gosh, well, they didn't do as good a job. Well, that's not quite true. The Sagittarius A star image, even though it's closer, 27 light years, we have to peer through the plane of the Milky Way galaxy, and it's really a dirty, gaseous, star-filled plane. So to correct for all of that is a big challenge. But the other problem is that the amount of material that is falling into the event horizon of our black hole is much, much less than the amount of material that's falling into M87. So our black hole has sort of been semi-starved, so as to speak. But it's also much smaller, which means that the orbital period time, if you will, of material that falls into the accretion disk around the black hole, the orbital period is really, really quick. We're talking about minutes, whereas over at M87, it is days to weeks, I believe, for the light to sort of move around. It's just that much bigger. Well, it's probably days, not weeks. But, days versus minutes. That means that when you're taking long time exposures of data for Sagittarius A star, you're blurring your image just by virtue of the fact that the image isn't steady. It's like trying to take a photograph of the car that zips by you at sort of like 100 kilometers an hour, and you're trying to get a quick snapshot. Well, it's a little bit blurry by virtue of the motion, the relative motion. So our Sagittarius A star image of the black hole is a little blurrier, but nonetheless, you can tell that both M87 and Sagittarius A star are images that are being formed with the same basic physics. So, similarities, but different.
Definitely. And you can definitely tell when they have the different kind of structure that you can see. There are like different nodes inside the black hole image that are just a product of how matter is accreting around the event horizon disk.
Yep. Correct. Very, very neat physics, and again, a triumph of general relativity, because the actual size of the black disk that's silhouetted by the brighter surround is where the event horizon is, and you can measure that diameter and compare it to the theoretical projected size for the mass of the black hole, and again, relativity does an excellent job in comparing or predicting the expected size. So every aspect of this story is terrific, and it shows what the Event Horizon Telescope is capable of. Expect to see more dramatic images from this consortium as the years go by. They have the technique now. They're obviously learning as they go. Their processing processes are becoming more refined. You can expect to see more images of either these black holes, because of course, changes in time, but I would expect other galaxies' black holes are also going to be targeted in the coming years. So yeah, really good stuff from the Event Horizon Consortium.
Yeah, definitely.
I tell you what, go on.
Sorry, go ahead.
Well, I was going to bring us back to the moon for our last story while we still have a few minutes.
Yeah, my thoughts exactly.
Excellent. Okay. All right. So this is certainly a change of pace. So no more black holes in this story. We're going to go and plant some plants. We're going to put some seeds down in some soil and see what happens. And you're probably sitting there going, well, what's so exciting about that? It's springtime in the Northern Hemisphere. Everybody's doing that, planting and watching the plants grow and so on. Yeah, but you don't have soil from the moon to put your plant seeds in. Well, that's what a Florida-based university group has just done. They were able to extract, and that really sums it up pretty well, they were able to extract something like 12 grams of lunar soil from NASA. Go all the way back to the Apollo era, Apollos 11 through 17, the 6 missions that went to the moon brought back approximately 400 kilograms of moon rock. About half of that has been analyzed to death in the ensuing 50 odd years, but put it another way, half of it is still in pristine storage, waiting for better geological analysis techniques to come up and therefore improve our understanding of lunar history, lunar geology, lunar geography. Well, NASA, with the advent of the Artemis project, I mean, it's not too long away now before Artemis goes back to the moon. NASA can see having a whole lot more moon rocks to play with. So they graciously parted with 12 grams of lunar soil. And this team from Florida planted seeds in there. Now, what type of seeds? Well, it's sort of like broccoli. Arabidopus thaliana. Help me out here, Gagan. It's a leafy type of vegetable, apparently. I'm going to call it
Yeah,
broccoli. It's similar to broccoli, apparently.
that
So,
works.
yeah, I think so too. I hate these long names. Oh, I'm just not good at it. At any rate, they took 12 seeds and planted it one per seed into each of these 1 gram samples. And they, of course, did similarly a control sample set of planting the same sorts of seeds in 1 gram of sort of volcanic ash, because, of course, that is somewhat similar to what is on the surface of the moon. And they of course, watered it with nutrients and so on and so forth. This was in a clean room environment. And then they waited. I think there was an expectation that nothing was going to germinate. But much to the surprise and relief, if you will, of the researchers, all 12 of the seeds, not just the 12 in the lunar soil, but the sample soil as well, everything sprouted. And up to about day 6, everything looked the same in the control sample as well as the plants that were growing in the lunar soil. And so everybody is going, this is really great. Unfortunately, thereafter, for the next 2 weeks, because they only ran the experiment for about 20 days, and then they sort of ground up the plants so that they could have a look at the RNA, DNA structure of those plants. But up till day 6, everything looked good. After that, the plants were obviously, the ones that were in the lunar soil, were showing signs of stress. Basically, it looked as if the root structure was having difficulty negotiating the lunar soil. Now, this in hindsight is not too much of a surprise. The lunar soil is breccia, and that soil is basically moon rock that has been shattered by billions of years of impacts. And so it really has got a lot of sharp corners, and it's just not the sort of pristine type of soil that you would find here on the Earth. Forget about the fact there's no moisture there and that it's been baked to death by harsh radiation. It is sort of, just not good soil in terms of its ability to compact itself. Obviously, the plants were having difficulty in this regard, but the sheer fact that all of them did in fact germinate was really very exciting. And why are we doing this at the moment? Well, if we're going to start putting people on the moon for extended periods of time, it behooves us to give them some degree of self-sufficiency. The Earth is, it's only a few days away, but a few days away, if you're getting hungry, is a long time away. So taking up food to the moon, that's also expensive. If we can utilize the lunar soil in sort of the right environment, a dome, a pressurized dome, we know there's ice on the moon, so we can get water, you apply the nutrients. If we can certainly find the way to get these plants to propagate and germinate successfully on the moon, then we're talking about being able to grow food on the moon for our astronauts. And who doesn't like a garden, eh, Gagan?
No, gardening, amazing hobbies. I would love to, if I was on the moon, I'd love to have a garden to, grow my little potatoes and tomatoes in.
All right, we're at the top of the hour, I'm afraid. For all you gardening enthusiasts, stay tuned for the next exciting round of Gardening on the Moon with Gagan and Paul. But you've been listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Alan I. Carswell Observatory here at York University in Toronto, Ontario, Canada. You will have 3 recorded best of the best over the next 3 weeks. We will not be back for 4 weeks live with you. But until then, clear skies to you all.
Have a great night.